this notation here is the same thing as saying this in longer. This is like the longer form. This is r times cosine theta plus I sine theta. Okay, so cis theta, that's cosine theta plus I sine theta. So we're trying to find a complex number, z equals negative 12i in the polar form. Remember how we plot complex numbers, right? This is the same as z equals, the real part is 0, and b, the imaginary coefficient, is negative 12. The way we plot this is the real number is 0, and the imaginary number is 12. Negative 12, we should say. So this is where this dot exists in the complex plane. So in order to make that happen with in order to convert it to polar form, in order to make this happen, the angle here is 270 or negative 90 degrees, whichever one. So theta is 270. So r is going to be 12 because it's 12 units away from the origin. And so we have everything they want for r cis theta. R is 12. And theta is 270. Let me see what they got for multiple choice selections. Yeah, that's all they want. They just want you to identify r and theta. Let's see, we're asked to express z equals negative square root of 2 minus square root of 2i in polar form. Let's see. We could plot this. It's a complex number, so here's the real plane, and here's the imaginary plane. So it's negative square root of 2 on the real plane, and then negative square root of 2 on the imaginary plane. So this point here is negative square root of 2, negative square root of 2. Okay, so we want that in polar form. So in polar form, for this same coordinate, we need to define a theta, so an angle. We need to define r, the distance from the origin. So r might be easiest here. R is this distance, so you could use the Pythagorean theorem. This is square root of 2, and this is square root of 2. So the negative square root of 2 squared plus negative square root of 2 squared equals the thing we're trying to solve for, r squared. A squared plus b squared equals c squared. Because we want to know the distance from the origin when we're talking about polar coordinates. So if we simplify, this is 2 plus 2, and I can do that. That's 4. 2 plus 2 is 4. And then take the square root of both sides, so r is going to be 2. So we know what r is going to be. We could define it with negative 2 if we want, but then we'd have to just switch out the angle theta. So let's just stick with r as positive 2. And then we need to know the angle theta to get down here. This is one of our special triangles though, right? For trig, you can make a right triangle here and start using sine, cosine, or tangent. But if you do, you're going to see, oh, wait, is this a square root of 2 or 2? I'm pretty sure that's a 45-degree reference angle, but I actually just started second guessing myself. So I'm gonna make sure. It is. It's going to be, because if you let this be your angle theta, then the opposite divide by the hypotenuse, that's sine of theta. Right? The opposite divide by hypotenuse. And we know this is a 45-degree angle from our special triangles. Or you could do it out, you could use inverse sine of both sides. You'll see that theta is 45. Or in other words, theta is pi over 4. Right? Because that's 45 degrees in radians. So the reference angle is pi over 4, but the full angle is pi over 4 plus pi. So it's this is 225 degrees. So this is 5 pi over 4. Theta equals 5 pi over 4. So we have the two things we need for polar coordinates. We have r and we have theta. So let's see which one matches up. R needs to be 2, which we've got in these two options and this option here. And there's our 5 pi over 4 that we just found for theta. So this is the correct option.